Raoult's law as a special case of Henry's law. See, we have done the Henry's law and we know that the Henry's law talks about the partial pressure of a gas present in the liquid solution, and it says that the partial pressure of any gas in the liquid solution is equal to the product of the Henry's constant and its mole fraction in the solution in the liquid state. So this is what is the formula we already know from the Henry's law. We also know from the Raoult's law, which talks about the gases, this talks about the volatile solutes. Now this also says that in case of volatile solutes, what we find is that their partial pressures are always equal to the product of their pressures in the pure state. Like if suppose this is B, this will be B, and it's their mole fraction in the solution. Here the B symbol is for the solute, which is actually your volatile solute. So the partial pressure of any volatile solute component in the solution, in the liquid solutions, is always equal to the product of their vapor pressure in the pure state and the mole fraction in the solution. So from here we know that this partial pressure of any volatile component is also proportional to its mole fraction in the solution, and in place of volatile solute we have a gas which is much more volatile. Its partial pressure is also directly proportional to its mole fraction in the solution. So this is how they both are similar. The only difference is that in case of Henry's law, we have a Henry's constant, whereas in the case of Raoult's law, the proportionality constant is the vapor pressure of that component in the pure state. So otherwise both are same. That is why we say that Raoult's law is basically derived from the Henry's law and is a special case of Henry's law, because in this case we are not talking about the gases, we are talking about the volatile solutes, which are very similar to the gases which have very little solubilities in the liquid solutions.